Okay, so we're going to start by talking about probability. Okay, the first term we're going to talk about is probability of an event. And when we say event, we're not talking about like, the winter formal or a bar mitzvah or a birthday party. We're talking about just something happening. What is the probability when you flip a coin that you will get tails? That is an event. Okay? All right. So the probability that an event will happen is a fraction, is a ratio. The number of favorable outcomes, for example, how many ways are there, for you to, get tails versus the total number of possible outcomes. Okay, how many possibilities are there when you flip a coin? 2. How many of those describe you getting tails? 1. So that would be 1 out of 2. Okay. All right. Okay. So let's talk about some vocabulary first. A sample space is the list of all possible outcomes. Okay. So when you roll a die, you can get 1, 2, 3, 4, 5, 6. That's the sample space. So what is the sample space when you roll a die? Well, you can get 1, 2, 3, 4, 5, 6. So it's basically what are all of the possibilities when you roll a die. We put those in these brackets. These are the curly brackets. That's how in math you describe like, a set of numbers. Now, if there are n outcomes, then the probability of each equally likely outcome is 1 over n. Okay, what are outcomes? Each of these things is an outcome. When you roll a die, what number you get is an outcome. Now, when you do roll a die, you get 6 possibilities, correct? And each one of them are equally likely to happen, right? So like when you roll a die, you're not more likely to get a 3 than you are to get a 1, right? You're equally likely. So if there are, the probability of getting each one of those is 1 over the total 6. So what is the probability of rolling a 4 on a die? Well, it's 1 out of 6. That's the ratio, right? And often we write that as a decimal, 0.17, which is 17%. So again, let's go back to our initial equation. The probability of rolling a 4 on a die. The favorable outcome is you getting a 4. How many possibilities is that? 1. You got a 4. Over the total number of possible outcomes, 6. So it's that formula, 1/6. Okay. The probability of an outcome is always between 0 and 1. Okay? So you either don't get a 1 if you wanted to get a 1, like if you wanted to roll and get a 4, let's say. You either don't get it or you do. So it's between 0% or 100%. Okay. In this lesson, it's very important for you to be able to, like on your feet when it comes, or like on your toes when it comes to like, decimals, percents, and fractions. Okay. A die is rolled. Find each probability and write it as a ratio. Okay? What is the probability of getting a 2 or a 3? Okay, so the notation for this is the probability of a 2 or a 3. Okay? So there are 2 possibilities here out of a total of 6, which is 1/3. Okay? What is the probability of rolling an odd number? So P of odd. How many different odd numbers are there? 3, right? So it's 3 out of 6, 1/2. That means when you roll a die, you get a 1 out of 2 chance that it's going to be an odd number, right? Okay. How about rolling a 5? P of 5. 1 out of 6. Not rolling a 5. 5 out of 6. So we say P not 5. 5 out of 6. Okay, so when you roll a die, the probability that you're going to get a 5 and that you're not going to get a 5 are complements, right? So the event for rolling a 5 and for not rolling a 5 are complements, because the probability of rolling a 5 plus of not rolling a 5 is what? 1. It's 1 over 6 plus 5 over 6, 1. Because there is no chance it's going to be anything else. You're either going to get a 5 or not going to get a 5. That means the sum of probabilities for any two complementary events is always what? 1. Good. Okay. And now come the, the standard problems. You have done this in middle school.
I love it.
And some, okay, good. I'm very happy to hear that.
It's literally my favorite.
Oh, fabulous. Okay, a bag contains 3 red marbles, 6 blue, and 5 yellow. 1 is chosen at random. Find each probability. Okay, so first you need to know how many. So in these, what's the total? Total is 14 marbles. Okay. Write each probability as a ratio, a decimal, rounded to the 100th place, and a percent, rounded to the nearest percent. Okay. Now, we are now in our last quarter of geometry honors. We are like deep into, our way into algebra 2, right? On this test, I'm really going to pay a lot of attention, this test and quiz, on you paying attention to which place you have to round to, okay? So this is what we're going to be working on this chapter, all right? It's one of the things. So, okay, what is the probability of getting a blue? So you say P, you can either say B if it's not like, if it's clear, right? Or you could just write out blue, okay? So how many blues were there? 6 out of 14. 3 out of 7. That's the ratio. That's equal to 0.43. 100th place, 2. And that's equal to 43%. Okay? All right. So red or yellow. So the probability of getting R or Y, it's 8 over 14, which is 4 over 7, which is about 0.57, and that's 57%. Okay. So P of not red, how many? 11 over 14, which is 0.79, 79%. Okay, then the probability of neither blue nor red, so not B or R, is it 9? It's 5. So not blue or red, it's just yellow, so 5. Which is 0.36, which is 36%. Okay, so when we had to list the sample space for rolling a die, it was very easy. It was just 1, 2, 3, 4, 5, 6. But when things are a little bit more complicated, then that doesn't work as well. When you have like different levels, then we have to have different ways of showing the same thing. One of those ways is a tree diagram. A tree diagram is also used for counting the number of possible outcomes. Okay, what you have to do, this is where some students get confused. You have to make sure that you use the last column for all the possible outcomes. So you don't count everything else. You just look at the last column. What do you mean by that, Miss Malikian? Well, I'll tell you. We're going to draw a tree diagram for the different options of ice cream. You can choose between a sugar cone and a waffle cone. All right? You can choose a scoop of vanilla or chocolate, and you can choose sprinkles or nuts for a topping. So lots of possibilities. You can get like a sugar with vanilla and nuts, or you can get sugar with chocolate and nuts, right? Like so many possibilities. So here's how we do it. You start with the first layer. The first layer is you get a sugar or a waffle cone. So sugar or waffle. Make sure when you're using symbols like this that like they're not ambiguous, right? If you have two things that start with an S in that first level, make sure you specify. Now, for each of those, you can get either vanilla or chocolate. So here you can either get vanilla or chocolate, and here you can either get vanilla or chocolate. Now for each of those, you can either get sprinkles or nuts. Okay, so either sprinkles or nuts. Okay, whoops.
So many options.
I know.
I kind of want ice cream right now.
I know.
I think we should go on a field trip.
Okay,
And we can do a probability problem on the way there.
okay,
Are you down?
sure. Yes,
Can we draw it this way?
which you can. Okay, so now this last row, the last column is all the possible outcomes. So how many possible outcomes are there?
8.
1, 2, 3, 4, 5, 6, 7, 8. Okay? Some students think like they have to count all of these. That's not the case. It's just like when you do a factor tree, it's everything that doesn't have anything else coming out from it. Okay? All right. Huh? That's not what it's asking though. It's asking how many different possibilities are there if you get everything. Okay. Okay. Now, fundamental counting principle. This is the way you can count possibilities. Because look, like if you got 31 flavors, you can't just get away with like a simple diagram like this, right? Like because you've got like all, like, or if you go to like Cold Stone or whatever, right? If you go to Menchie's, oh my goodness, right? So, there has to be a different way. You can't just sit there and do a diagram all the time. So the number of possible outcomes in a sample space can be found by multiplying the number of possible outcomes from each event. Okay? So, let's do one. So, for example, here, in the first event, sorry. You have 2 possibilities, and then 2 possibilities, and then 2 possibilities. And if you multiply 2 times 2 times 2, you get 8, right? That's another way of doing it. Okay. So Kathy needs to make a 4-digit password for a login on a website. The password can include any digit from 0 to 9, but the digits may not repeat. So we need to have 4 digits. 0 to 9, but the digits may not repeat. How many possible passwords are there? So when we're choosing the first one, from 0 to 9, there are 10 possibilities, right? Now, so you had 10 possibilities. Now you used 1. For the next one, you can't reuse that same one. So how many possibilities do you have left? 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 possibilities for that first number. Now, okay, now you chose your second one. Now you have 8 because you can't reuse the other ones. So how many possibilities now? 8, then 7. Okay? So to get the possible ones, you multiply all these. 5,040. Okay, so You have to create a 4-digit password. Boom, 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 boom. Give me a number for the first digit. It has to be 0 to 9.
3.
Okay, I heard 3 first. How many possibilities did you have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You had 10 numbers to choose from, correct? Now, we chose 3. Okay, 0, 1, 2, 3. We chose 3.
You 7
Now you have, no, we chose one number. 3's out. Now I have 9 possibilities for that one. Give me a number. 6. Okay, 6 is out. Now we have 8 possibilities left. Give me a number. 9. We haven't used 9 yet. Okay. How many numbers do we have now? 7. Okay, so do you see that with each one number, you have one less to make a choice from. Okay? So the number of possibilities you had for this one were 10 possibilities. Then you only had 9 possibilities. Then 8 possibilities. Then 7 possibilities. Okay? Still doesn't make sense?
Yeah.
Okay, let's do it this way. So, take a look at this one. I have 10 answers to put. Okay? 3, 4, 5, 6, 7, 8, 9, 10. For question 1, how many choices do I have? 4. For question 2, how many choices do I have? 4. 3, I have 4 choices. 4, 5, 6, I have 4 choices for all of them. And then the rest, I have 2 choices for each. So you have to multiply all of these, right? So how do we do it? This is 4 times 4 times 4. This is 4 to the 6, 2 to the 4. Altogether, it's 65,536 choices, different possibilities. Okay? 65,536. Because it could be like A, B, C, D, C, and then true, false, false, true. Or then it could be like another possibility, and then there are 65,536 of those possibilities. Huh? The number 4 to the 6 times 2 to the 4? No, I do them before. Yeah, that's why I have my notes here, so I don't have to waste time doing the math here. Okay? Question.
When you get 4 to the 6 and 2 to the 4, do you multiply them?
Yes, multiply them. So the fundamental counting principle says you multiply all of the choices. Okay, a die is rolled 4 times. The first time, how many possibilities are there? 6. So we're going to do it 4 times. The second time, how many possibilities are there? 6. Third time? 4th time? Multiply all these out. 6 to the 4, 1296. Okay? Okay. If you roll a die, you get 6 possibilities for what you get. Like if you roll a die, how many possibilities are there of what you're going to get? 6. But then if you roll a die again, how many possibilities are there now? And if you roll it again, and if you do it until you're blue in the face, still 6 every single time. Okay? Okay, the number of class rings that can be created. Okay, so there are 10 different metals you can choose. Okay, there are 10 different metals you can choose. For each metal, you have 2 different finishes. So for example, you can get platinum with like, matte or, whatever, right? You can get gold with, matte or shiny, you get, right? So just this alone, there are 20 choices because you multiply them all. So in the first round, you have 10 possibilities. Times 2, times 12, times 5, times 20, times 20, times 2. 960,000 possibilities. Okay? Yeah. So just like, remember, let's go back to the first one. You had a sugar and a waffle cone. That's 2 possibilities. And then you had chocolate and vanilla. So 2 times 2, that gives you 4 total possibilities. You multiply them. All right? Then you have 4. And then sprinkles and nuts times 2, so that's 8. Same thing here, but now you have like too many to do a tree. Okay? Okay. So